Hi everyone, welcome to another maths video by Maths with Sarah. Today we're going to be tackling this question, which is looking at calculating the volume of a sphere. And then there are a couple of other subsequent questions after that. So again, this question's a GCSE Maths question. It's question 10 on a calculator paper. So good news, you can use your calculators if you need them. It's question 10, so it's about halfway through the paper. So where they're starting to get a little bit more challenging. So as normal, I would encourage you to pause the video here, have a think about how you would tackle this question. If you can do it, then fantastic. If you struggle or you get stuck, do the bits that you can do, or think about the method you would use. Even if you can't actually do the whole question, think about what methods you need to use or what calculations you might need to do. And pop back in a couple of minutes after you pause the video, and I'll go through it then. Okay, so this question, we've got a container that's a hemisphere. So a hemisphere is just half a sphere, basically. So the word hemi often means half, and then sphere is obviously like a ball shape. So it's half a ball, kind of like a bowl. And we have conveniently been given the equation to calculate the volume of a sphere. So it's 4/3 pi r cubed, where r is the radius. And we have been given the radius of this hemisphere. And then there's a subsequent, so sand fills the container at a rate of 4,000 cubic centimeters per minute, and it wants to know how long. So does it take less than a quarter of an hour to fill this container? And as usual, you've got to show you're working. So the best way to tackle this question is we know the rate that it fills the container, and this is as a volume, so it's 4,000 cubic centimeters, so that's a volume. So the way that we need to do this is to start by calculating the volume of the entire container, and then we can work out how long it's going to take to fill. So to calculate the volume, we're going to do 4/3 pi r cubed, and we know that the radius, we've been given that the radius is 30 centimeters. So we do 4/3 pi times 30 cubed. And if you do this calculation, then you get an answer of 113,097 to the nearest whole number. And the units for this are centimeters cubed. So because we've cubed the number, the value, we also need to cube the units as well. So in that case, we're going to end up centimeters cubed, which is of course the units of volume. So all ties in nicely. Okay. But we have to remember is that this is the volume of the total sphere. And as we've said, we've only got half a sphere. So then we need to divide this by 2. And if we do that, then we end up with 56,549. Again, I've rounded this all to the nearest whole number. So if you left it, haven't rounded it, then you'll probably get a slightly different answer, but it will all work out in the end. We don't need to be that accurate. So now we've worked out the volume of the hemisphere, and we now need to work out how fast or how long it takes the container to fill. So we know that the sand fills the container at a rate of 4,000 cubic centimeters per minute. So in order to work out how long it's going to take in minutes, we need to divide the total volume by the rate, so or how many cubic centimeters it can fill per minute. So we're going to divide that by 1,000, and that is going to give us the answer of 14.14 minutes, which is the equivalent to about 14 minutes and I think about 8 or 10 seconds. And the units of this is just minutes because we've worked it out in minutes. So the answer to this question is yes, it does take less than a quarter of an hour to fill the container. So this question, I think, looks deceptively complicated. So when you look at it and you see that slightly nasty looking equation at the top, and you think about all the different steps that you think you've got to do 2 or 3 different steps to work this out. It seems quite complicated at first glance, but in actual fact, when you break it down, you're substituting the number into this equation. I think the hardest step actually is remembering that you need to divide it by 2 to work out the hemisphere as opposed to a full sphere. And then lastly, you're just dividing it by the rate. So in actual fact, I think this calculation or this question is slightly more simple than it looks at first glance. So hopefully you were able to follow that all the way through, and it helped you to understand how to work out this question. If you've got any requests for particular questions that you would like me to go through, just drop me a message. And remember to subscribe to the channel so that you get the first look at any new videos. Finally, thank you for listening.